All right, so this video is going to be on slope and the slope of a line. So first of all, you need to know what slope is. It's represented usually by an M. It's also represented by rise over run, and that's kind of like how the graph looks. So I'll explain that when we look at a graph. And then it's represented by a formula, y minus y over x minus x. And they put ones and twos on here. It could be switched. Really, you're subtracting the y's over the x's. This point and this point must match. And that's why they put the ones and twos on there. It's the change in the y over change in the x. It's really the steepness of a line. So if I want to describe a line to somebody, I can tell them the slope and it's going to tell them how steep the line is, right? So if it's 0, it's not steep at all. It's flat or horizontal. And if it goes up to 1, maybe it's a little bit more angled. If it's 2, it's a more angled, 3, 4, and so forth. But then it gets so steep that we don't define it. So the horizontal and vertical lines are a little different. Okay, so let's look at a horizontal. Let's define what a horizontal line has 0 for its slope. And that also would represent, when you do the formula, when you have 2 points, you get 0 over some number. So that's kind of what you get. So 0 divided by anything, 0. So a horizontal line, so if I have a vertical line, it has no slope. Or it's undefined. And that one would be represented by some number divided by 0. I can't divide by 0, so that slope is undefined. Okay, so let's look at a couple problems. So here would be my first example. If I have the points 2, -1, and -5, 3. So here's 2 points of a line, and I would like to find the slope. If I have 2 points, then I'll just use my formula. Y minus y over x minus x. And yes, you could go this way, either way that you go. So -1 minus 3 over, so I went this way, right? So I have to go this way as well. So 2 minus the -5. So be careful of those double negatives. -1 minus 4, or 3 is -4. This is going to become plus, so you get a +7. So our slope of those points is -4/7. What if I had, here's y, my x, what if I have a line and it's on a graph? I should have grabbed some graph paper, but that's all right. Just use my ruler and it'll look pretty enough. So if I have a line like this, and I want to know the slope, there's 2 ways you can do that, and we'll assume this counts by ones. So there's 2 ways. You can just write the 2 points down and do the formula. That works. Or you can do rise over run. You always go to the lowest point. How far up and over do you go? And the reason why I start always at the lowest point is if it would have went up and to the left, it would have been shaped this way. It would have had a negative slope. Negative slopes are a little harder to see from a graph, but still possible. So I could count up 1, 2, 3, 4 over 1. So the slope of this is 4 over 1, or 4. And let's see what that would look like using the points. So this point here is the point 3, 0, and this point here up here is the point 1, 4. So then I would subtract, right? So 0 minus 4 over 3 minus 1. 0 minus 4 is -4. 3 minus 1 is 2. I'm not getting the same slope. Did I write my point? points down. 3, 0, 1, 4. Let me finish. I got negative 2. 0, 3, 0. Oh, shoot, that's why. I wrote this down 4. All right, can you tell it's early morning? I'm trying to get this lesson done. I got to slow down. I was like, oh, that's wrong somewhere. So over 4, over 4, up 4, not over 1, up 4. So my logic, I think, went to, oh, I went one more out. I didn't count over 4, up 4. You guys probably noticed already. Anyway, so let's try again. So 0 minus 4 over 3 minus 4 is going to give me negative 4 over negative 1, which reduces to the positive 4. So you should be able to see, if you got something like me, negative 2, the slope does not go in this direction. It doesn't fall to the right, so it's not negative. So I really did something wrong. Okay, so we can see the slope this way as well. So you can write your 2 points down as long as you write them down right, and you can get your slope that way, or counting up and over. Do one more example. What if I had something like, all right, so here's 1, negative 3, and 2, negative 3. First of all, what do you notice about the points? What do they have in common? Yeah, they both have the same y. That's going to make a horizontal or vertical line. If they're the same y, and the y's refer to y equals a certain number refers to horizontal, it's probably going to be a horizontal. So we're going to go negative 3 minus the negative 3, 1 minus the 2. A double negative is a positive, so this really becomes 0 over negative 1. Anything divided by 0 divided by anything is 0, not undefined, 0. So that is a horizontal line with a slope of 0. What if I am looking at an equation? A couple more things I got to make sure we cover here. What if I'm looking at an equation? What's the slope? So let's go in a different direction. We know y equals mx plus b. This is slope-intercept form, and m represents slope. B is the y-intercept. Remember, y-intercept is just where you cross the y-axis. What if it's in standard form? That is ax plus by equals c. So those are our two main forms. We have slope-intercept and standard form. If it's in standard form, what's going to be your slope is it's going to be negative a over b. So you can actually see the slope in both situations really easy. The number in front of the x or negative a over b, because if I solved for y, I would subtract that over and divide by b. So that's where the negative a over b comes from. So a lot of people go through the whole process of solving for y in order to see the slope, when you can see it in the form, the standard form. Remember, if you have y equals some number, that's horizontal, so that's 0 slope. And if you have x equals some number, that's vertical, and the slope is undefined. Or there's no slope. I kind of like using the word no slope, but either way. So those are kind of like what we'll use for my next couple examples. What if I have the equation 2x minus y equals 10, and I want to know the slope of that line? So lots of things I could do to find it, right? I could graph it, count up and over. I could solve for y, and then I could see the slope and the y-intercept. If you're asked for both the slope and the y-intercept, that is the best way to go. But if you're asked for just the slope, I would go negative a, so negative 2 over b, negative 1, or 2. So the slope of that line is just 2. So you can find it pretty easily. So if you were asked for the y-intercept, though, then I would go through the process of solving. So minus your 2x over, remember, you can't really combine a 10 and a 2x, so you would have negative y equals negative 2x plus 10. Notice I wrote that negative 2x in front of the 10 when I moved it over, because we usually see the x first. It doesn't really matter. As long as you recognize that the number in front of x is always the slope. But I can't leave y negative, so I got to divide or change all the signs. Divide by negative 1, and this would be the formula, or standard form to slope-intercept form. Slope-intercept form. Can you see the slope of 2 that we already found? Yeah, and then you could also see the y-intercept. Remember, the y-intercept is where x is 0, and then the y would be 10. So it's a point where x is 0 and y would equal this number here, or the y-intercept is negative 10. Okay, let's look at let's define these. Let's define parallel lines. They have the same slope. So parallel lines have the same slope. Perpendicular lines have, so let me write perpendicular. So perpendicular lines have the negative, they don't go off my paper, no, negative reciprocal slopes. So negative reciprocal. So remember, reciprocal means to flip it over, and obviously opposite sides. So we have this relationship with this slope or the steepness between parallel and perpendicular. Well, think about parallel lines, right? They have to have the same slope. You want them to have the same steepness, but their y-intercept would be different so that they're in different places. And then look at perpendicular. They have to cross specifically at that 90-degree angle. So their slopes have to be the opposite of each other. So flipped over, opposite sign. So that's kind of the way why we have those two special cases with the slope. So let's look at a couple lines. So what if I have y equals 1/2 x plus 3, and I have y equals negative 2x minus 1. So look at those two equations. Are they parallel, perpendicular, or neither? All right, so let's look. The slope is 1/2 and negative 2. So is this one, if I flip the 1/2 over, I get 2 over 1. Does that equal this one? Yes. Are they opposite sides? Yes. So this is perpendicular. So let's look at, what if I have x plus y equals 4, and I have y equals negative x plus 4. Oh, I can't have it plus 4. Plus, sorry, 8. I should have wrote down an example. I was doing one in my head. I wanted to make them look a little different to where you can't quite tell exactly right off the bat what they are. But okay, so one's in standard form, one's in slope-intercept form. So looking at the standard form, what is the slope of that top line? The slope is equal to a over b, which is 1 over 1, opposite sign of a. So it's negative 1 over 1 or negative 1. Okay, slope down here is equal to negative 1. Number in front of x, we assume a 1, right? So our two slopes are the same. So what are these lines in relationship to each other? They're going to be parallel. Parallel. Is that an E? I don't know. Maybe that's an E. No, it's got, okay. Oh, well. I spelled it wrong? Okay. It's all right. Okay, so that's kind of the idea of the slopes and looking all the way through parallel lines, perpendicular lines. Don't make slope hard. It's just a number that you find that tells you something about a line.